So this was the question that we tried last time for a doubly reinforced beam section. What we are going to do, we are going to change the load on the section. So we are going to revise the question itself, because we want the question to be such that it is will this is the question now. Design a doubly reinforced beam section of dimensions 250 mm cross for 75 mm. The load on the beam is now, how much was mu coming out to be? It was 153 and mu limiting, and mu was 107, so around 50 times more. So the load on the beam is, let's take it 8 kilonewton per meter is dead load. 2.97 kilonewton per meter is the self weight. Live load is 25 kilonewton per meter, or let it be 30 kilonewton per meter. The section is to be designed in 30, let's keep it 40. The section is to be designed in M25 grade concrete and Fe 500 steel. Length of beam is 5 meter. So I revised the question. Now step number 1 is similarly you are getting step number 1, calculating the moments and shear forces for this beam, which is 5 meter in length, and with load now being, how much is the load now? The load is now 8 plus 2.97 plus 40, 50.97 kilonewton per meter is the total load. So your bending moment diagram is this. So this will be mu value. If you take from here, wu is now 50.97 into L square. L is 5 square, that's 25 divided by 8. So this is 159.28. 159.28, yes. 159.28 kilonewton meter. No, you have to multiply it by 1.5. This you have to multiply by 1.5. Just a minute. So mu is 1.5 times 50.97 into 25 divided by 8. So that is 38.92. And your shear force is this is Vu is WL, that's 1.5 into 50.97 into L. L is 5 divided by 2. So that is 191.13. Now, your second step, which was fixing the dimension like this, we have already fixed the dimension. So we just have to take this. It's already given in the question. This is the step number 2. We are fixing the dimension. B is 250. D is 475. D is 475 minus 30 minus 8 minus 8, 16 by 2. That's 429. And D dash is 44 mm. Now, D minimum required as per this formula would be so how much would that be required? D minimum for this section as per this formula. This would depend upon, first of all, it depends upon the mu limiting. Now that is this. And we have not changed any of these parameters. So mu limiting is the same. Now our section has, now this is the case, your mu here, which is in the red here, mu is greater than mu limiting. We'll not say this is mu, so it's mu limiting. Your mu is greater than mu limiting. How much? How much is mu? That is, your mu is 238.92. Is greater than 153.68. What does this mean? इसका क्या मतलब है? That the section जो हमने section दिया है, it's not able to take all the load. The section would become over reinforced if we design it in this manner. This means that your XU is less than XU max. So thereby the section is becoming over reinforced. But we have to keep the section under reinforced. Just a minute. I'll have to answer a call. Let's continue. Now, in this question, we have mu is greater than mu limiting. What does this mean? इसका ये मतलब है mu limiting से ये पता चलता है कि concrete how much the compressive load or the compressive moments can the concrete take, and what is the total amount of moments that are on the section, that is mu is 238.92 and mu limiting is what the concrete can take. In singly reinforced section हम वहां पर क्या करते थे, what we used to do is we used to increase the size of the section, we used to increase the breadth and the depth. But here in the doubly reinforced section, you do not have that choice. You are not able to increase the dimension of the section. Or what is the other way around? You could increase FCK, but there may be a limit to the amount of FCK that you can increase. It may be dependent on various things. Like for example, you have design mix. When you are preparing a design mix, आपने एक question किया. What you realize is that with the increase in the design mix, you have to actually go with decrease in the water cement ratio, and you have to go with increase in the cement content. So there may be a limitation to that. And then with the increase in the FCK, you require admixtures. You do not want to include admixtures or super plasticizers for workability purposes. You do not want to include them. So there is a limit to FCK as well. Now, in such a case, when you have limit to dimensions as well as to the FCK, and your MU is coming to be greater than MU limiting, in that case, what do you do when your MU is greater than MU limiting? Then we go for a doubly reinforced section. Now, how do we do this? Is first of all, we determine, we have now determined MU. Let's first determine if it's MU limiting, what is the value of uh, AST or AST limiting? What is the value of AST limiting? Now, what is AST limiting? AST limiting is your this you can say is the amount of steel required for a section with MU limiting, which is which can take MU limiting moments. Section which can take moments which are equal to MU limiting. इसका क्या मतलब है? When you have now a section with, for what does MU limiting tell you? It's telling you the moments that is taken in compression by concrete. It will tell you the amount of compressive loads taken here by concrete, and thereby it's telling you the amount of compressive moments taken by concrete. Corresponding to that, you have steel here. Now, this steel will also take certain moments. How much will that be? It will not be greater than AST limiting for a balanced section if the section was balanced. But now you require how much is the actual amount of movement for this has to take. It is MU. Now what is MU? It's MU limiting plus MU is the total moment that the section has to, for which the section has to be designed. Now that will be equal to MU limiting plus certain delta M. So corresponding to that, what is MU limiting dependent on? It's dependent on the breadth of the section, this breadth. It's dependent on the depth of the section. It's dependent on FCK. What is delta M going to be dependent on? how will you provide the additional moments that is for which it has to be designed? How will you provide that? Delta M? Yes, anybody? How are we providing that? We are providing it by compression reinforcement. The additional moments that it has to take in compression first. पहले हम compression side देख रहे हैं. This always has to be balanced. Remember this. Your compression has to be always equal to T, or your C has to be less than T if the design is under reinforced. Thereby, what are we trying to do? First of all, in compression side, your mu is mu limiting plus delta m. Now, delta m kaun lega? It will be taken by this compression reinforcement. Corresponding to mu limiting, the amount of steel on the compression side, this is something like this. आप इसको ऐसे समझो, जब mu limiting compression side पे forces है और movements है, उसके about AST limiting tension side पे you have the steel, और you can say mu limiting के about जो आपका B and D है उसके about टेंशन साइड पे आपका AST लिमिटिंग टेंशन स्टील है. अब जब आप एक्स्ट्रा कंप्रेशन रीइंफोर्समेंट यहां पर कंप्रेशन साइड पे दे रहे हो corresponding to delta M, then there will be additional steel AST on tension side which you have to provide. Why do you have to provide that? Because you have to balance. For a balanced section, your compression forces should be equal to tension forces. AST limiting किसके about balanced है? MU limiting के about. When now you are adding compression reinforcement on compression side, then you have to provide AST also on the tension side. Thereby, now your AST on tension side total is equal to AST limiting plus AST additional which you are providing corresponding to जितना आपने compression side पे reinforcement provide किया. Let's keep it as AST or let's keep it as delta AST. The additional reinforcement that you have to provide on the tension side such that the sections become balanced. तो पहली चीज है, first we have to determine how much is AST limiting. So from code you can get this, or SP16 you can use. What is given in the code? Let's go to the code. So what is given in for a sections with compression reinforcement in code page 96, where the ultimate moment of resistance of section exceeds the limiting value, mu limiting means जब mu is greater than, it means when your mu is greater than mu limiting, then compression reinforcement may be obtained from the following equation. Now your compression reinforcement will be obtained by this. Mu minus mu limiting is equal to FSC into ASC into D minus D dash. This mu minus mu limiting is your delta M, which I was just talking about. Because I told you mu limiting plus delta M, your mu limiting plus delta M is equal to the total moment, which is mu, which is acting on the section. So your mu is mu limiting minus plus delta M, or your delta M is equal to mu minus mu limiting. तो ये है delta M, which the code is saying. Now that delta M वो किसके about है? I just told you. I just showed this to you. This delta M is the compression reinforcement that you are providing. Corresponding to delta M, you are providing the compression reinforcement, जो आपको additional reinforcement चाहिए. So as per code, then this is how you provide the compression reinforcement. But before going into that, the total area, go to this line, the total area of tension reinforcement shall be obtained from the following equation. AST is AST1 plus AST2. Now AST, the total area of tension reinforcement, AST1 is corresponding to area of total tensile is AST. AST1 is area of tensile reinforcement for a singly reinforced section for mu limiting, जिसकी मैं अभी बात कर रहा था. AST1 is equal to AST limiting, which I was just telling you. So this is AST1 here in the code is AST limiting, which I was telling you. And AST2 is now given by the code. It's ASC into FSC divided by 0.87 into FY, corresponding to जो आप provide कर रहे हो the compression reinforcement. Now ASC क्या है? Area of compression reinforcement. That's what I was telling you. जो आप additional reinforcement यहाँ पर provide करोगे, this AST additional apart from AST limiting, what will that be dependent on? आपने compression reinforcement कितना provide किया, उसको balance out करने के लिए you are providing AST additional AST on the tension side. तो वो, so it's dependent on ASC into FSC divided by 0.87 FY. ASC is area of compression reinforcement. FSC क्या है? FSC is your design stress in compression reinforcement corresponding to strain of 0.0035 into XU max minus D by XU max. So it's almost corresponding to 0.0035 maximum जो compression में stress strain develop हो जाता है in a beam, because this will all D dash is very small amount. तो ये कैसे निकलता है? Let me show you. What is happening is when you are calculating the strains, this is how you calculate the strain. So your maximum strain here is 0.0035. What will be the strain at this location corresponding to compression reinforcement? It will be 0.0035 into वही जो XU max. So it's from the similar triangles, because this value is here, this value is XU max for a balanced section. This is XU max from this point up till this point. So this comes out to be XU max, जो कोड लिख रहा है, XU max minus D from single triangles in minus D dash by XU max. D dash है ऊपर वाला cover, effective cover for the reinforcement. So that's FSC is design stress that you have to determine corresponding to this amount of strain. So your FSC is this value, then you know 0.87 by Fy. So this is actually FSC by 0.87 Fy का ये मतलब है, this is giving you the relative amount of stresses in the tension reinforcement corresponding to the compression reinforcement which you are providing additionally. और इसको मल्टीप्लाई ASC के साथ इसलिए किया जा रहा है बिकॉज यू आर एक्चुअली बैलेंसिंग आउट द कंप्रेशन रेनफोर्समेंट ऑन द टेंशन साइड. जो हमने डिस्कस किया, वी आर एक्चुअली बैलेंसिंग द स्ट्रेंथ. So you are balancing the strength on both sides. AST is balanced with the compression side strength. Thereby, now your mu minus mu limiting, which is delta m, then finally becomes FSC into ASC minus D dash. So, so how much is now our AST limiting corresponding to can you now calculate the AST limiting? How would you calculate? Just give me an idea. How would you calculate? First of all, I want to hear from you. How would you calculate for a balanced section? आप AST limiting कैसे calculate करोगे? Yes, anyone? Nobody?
By using the mu limiting, sir.
By using the mu limiting. So your